All right, this morning we're going to be discussing the effects of the index troll. And it might be, excuse me, a little unfair to call him a troll, but generally speaking, an index troll is an individual who will basically throw an index on every column on a table. And it is true that we generally, there's an old saying, we judge other people by their behaviors and we expect other people to judge us by our intentions. And I'm going to say that usually the person who does this or the individual who does this actually is trying to speed things up. Sometimes they're just doing it in a hurry, but a lot of times they're trying to speed it up. So they are trying to improve the speed of a query or how things work in the database. The problem is they don't understand the effects of throwing an index on everything. So now I spent 2 hours developing these test cases. There's no way that I'm going to record a video that's 2 hours long just to demonstrate this. So instead what we're going to do is we're just going to cover the results of the test. And I'm going to show you the table that I did this test on. So we'll see that we have a table that has an ID field that increments. We have column 1, column 2, both of those are new IDs. You can look that up in SQL Server, and then we have a column date. Okay. In test case 1, I indexed every one of these columns as well as a fifth index which combined ID and date. Okay, that's test case scenario number 1. It has 7 million rows of data, so the first insert before there were any indexes was 7 million rows of data. So there were no indexes, added 7 million rows of data. Then I built the indexes. So after the 7 million rows were added before the indexes, the total cost as far as our MDF space was 0.6 gig. This is after test case scenario 2, but this is the MDF file right here. Okay, so after the 7 million rows without any indexes, 0.6 gig. After the 5 indexes were added, it jumped to 1.7 gig. Now the fill factor was 70%. I used fill factor of 70% for all of this test, so it's the same. Then I added another 10,000 rows of data. Now this is very important. It took 4 minutes to add 10,000 rows of data. You'll see why that's important in a second. Then I re-indexed, and by the way, after adding 10,000 rows of data, I believe the space jumped by about 10 to 20 meg, but not much. So then I re-indexed again at a fill factor of 70%. And the space requirement, so it went from 1.7 gig to 3.9 gig. Okay? So then I added another 10,000 rows of data, re-indexed at a fill factor of 70%, and it went to 4.4 gig. So let's think about that for a second. So we have our 7 million rows, no indexes. We build 5 indexes, we add 10,000 rows, we index at a fill factor of 70%, then we add another 10,000 rows, we index at a fill factor of 70%. In the 2 times that we added 10,000 rows, it took about 4 minutes to add those 10,000 rows of data. We went from 0.6 gig with 7 million rows of data to 4.4 gig after re-indexing twice and only adding a total of 20,000 rows of data. So that's test case scenario 1. And I'm going to just put that here, test case 1, 7 million rows of data, 5 indexes, 10,000 rows added, re-index FF, that's fill factor of 70%, 10k rows added, and then re-index FF 70, and then ending at 4.4 gig. And this would be starting at 0.6 gig. Okay, great stuff. Kind of gives us, a perspective of what's going on. All right, so now we're going to deal with test case 2. Now in test case 2, we have the same starting point, right? We have 7 million rows of data, again, which is 0.6 gig. Nothing changed here. I mean, I had to shrink the database, the data file, and everything, but other than that, once I restarted, dropped the tables, cleaned everything up, I'm going to move this down here. Everything looked the same. Instead, this time I'm going to add 1 index. Now, Just like there's an index troll that adds indexes on everything, there's the opposite index troll, which is no indexes or very few indexes. In the case of this table, I would have to assume how it's used. This is just a test table. Generally speaking, if I were to look at a table like this, I'm going to be eyeing these two columns for indexes, the ID column and the date column. There's a reason why. These two, not so much. It would really depend on how it's used. So I can't give a concrete answer. This is just a test. This is an arbitrary test. But probably the ID and the date are going to get the index. And depending on how the queries are used, maybe only one of them will get the index. But I want to compare, and this is the purpose of this test case. So we're going to throw in one index. So the ending cost, remember at 5 indexes, we had a cost of 1.7 gig. Okay, and of course that makes total sense. With one index, we end at with a the MDF file is 1.4 gig. Okay, and then of course, like the previous scenario, I went ahead and added 10K rows. Okay, and again, the size here basically stayed the same in both cases. If you want to consider a 10 meg increase or a 10 to 20 meg increase, it wasn't that much. Okay, so now I'm going to do the first re-indexing. So I'm going to re-index fill factor of 70. Okay. And the first time that I did the re-indexing of fill factor 70 here, I ended at 3.9 gig. Okay. On this other scenario, when I re-indexed the first time, it was ending at 1.6 gig. That's a huge difference. Okay. Well, again, 5 indexes versus 1 index. And more than likely, only 2 indexes are needed in this example if this was a real table. So I went ahead and added 10,000 rows like I did up here. And then I re-indexed again at a fill factor of 70%. And it ended at 1.9 gig. Okay, so this was the ending scenario. Okay. So, and you can see it's 1.88 to be exact, but I've just rounded up a little bit here. So, why is that important? Okay, so there's a lot of different pieces to indexing, right? And it would be easy to get into, a lot of the other stuff, which there will be future videos, discussing fill factor and everything. But I want to focus specifically on space and storage and the effects on your MDF file here, and just keep the focus there. What we have going on is indexing every column from a space perspective is going to obviously consume more space. There is a reason why, and it is going to affect performance. I'll give you just a thought process. On both of these 10K ads, it took 3 seconds. In these 10K ads, it required 4 minutes. Now, I want you to just stop for a second. You can pause the video and think about why that is and Google it. I'm not going to answer it in this video, but there's a reason why it took 4 minutes up here and there's 3 seconds down here. And you can run these test scenarios yourself, but at the end of the day, it's going to take a lot of time. I'm going to warn you, it took about 2 hours to complete all this, so it's great to look at someone else's results without doing the test on your own. It's great stuff. So it does affect performance. Re-indexing is going to take, quite a bit of time. Throwing an index on every column on a table is not a solution necessarily to enhancing performance. There might be exceptions to that rule. I'll give you an example of a table that I might consider adding an index to every column. If I have a table that has salesperson ID and salesperson, I have 10,000 different salespeople. I know that I'm probably going to use a salesperson ID on a join. So yeah, index on that would be very handy. Every now and then, I may have queries, and again, it will depend on the actual database and the queries. I may have queries that are looking for specific salespeople. So an index will allow sortability if I index salesperson. 10,000 rows of data, an index on both of those columns, it's a small table, it's not going to be a killer. Again, it all depends on how much the table is used. If it's almost never used, probably salesperson ID is really the only thing that needs the index. The only column, I should say, that needs the index. So when we're evaluating this in SQL Server, it's important to just note and to think about this when we're indexing columns. throwing an index on every column is seldom going to be the answer to the problem. Likewise, I would say, depending on how this table is used, if we're using ID and column data a lot, throwing an index on ID is probably not going to mean much. Throwing an index on date is probably going to mean more. In fact, knowing what data are in this table and how this table could theoretically be used, the priority of an index is going to more than likely start actually on date than it would on ID. Generally speaking, with an ID field, I would index the ID field if the ID field is going to be referential. If the ID field is just an auto increment just for the sake of auto incrementing, more than likely that's not a very highly important column to index. So these are some things you can play around with your test scenario. It will depend, because again, where your bottleneck is with your environment will depend on the results that you get. But it's just really fascinating to look at these test case scenarios, to compare, look 1 index versus 5 indexes on storage, as well as adding rows to the table. One of the reasons why you'll hear people say generally you want to drop the indexes before adding data, like bulk loading, bulk inserting, drop the indexes and then rebuild them. Again, that's because there's an effect of indexes on actually adding data. So if you want to play with those test case scenarios, otherwise this video, I know there's no code here today, but again, I don't think most of you want to watch 2-hour video just to see this results. Instead, you get to see the results of the test without actually going through 2 hours of watching everything being added and dropped and everything.